In this video, we will see another routing protocol, a Cisco specific routing protocol, EIGRP. For our EIGRP configuration example, we will use the topology on the screen, and as you can see, there are 4 routers and 4 PCs. And the IP configurations has already done. Let's start the EIGRP configuration. We'll start with router 0. Firstly, we need to enter the router mode, router EIGRP mode, and then we will add the networks under this router EIGRP. You can also use wildcard bits here, but I'm not used for here. And we will say no auto summary. And for the other router, and our neighborship is established. For this router, let's verify our EIGRP neighbor because our neighborship has established with router 0. As you can see, here is the router 0. You can also see the EIGRP interface of this router, these 3 interfaces. And here also the networks under this router EIGRP. And let's configure the router 2 and router 3. Here I will also use a passive interface commands, and passive interface default, so all the interfaces of this router will passive, and I will use no passive interface command for fast Ethernet 5.0. And let's verify our EIGRP neighbors. As you can see, the only neighbor is here now with router 0, and the only EIGRP interface is fast Ethernet 5.0 because the other interfaces are in passive mode. And let's conclude our configuration, and let's do the configuration on router 3. as you can see, the neighborship is established only with router 1. It's not established with router 2 because the router 2's fast Ethernet 4.0 port is in passive mode. And let's see the EIGRP interfaces. As you can see, the 3 interfaces of the router is on EIGRP. And let's see the IP routing table. And as you can see, there are routes in the routing table which are learned from the EIGRP. You can see them with D. And if you want to see only the EIGRP routes, you can use EIGRP keyword. And you can also see the EIGRP topology table. And let's verify the configuration now. Our PC 0 IP address is here, and let's ping the other PCs. The PC2, it is pinging. The first one is because of ARP. The PC1, it is pinging, and the PC3. As you can see, it is also pinging. Let's also verify our routing tables, because in routing protocol configuration, the routing tables is very important. Yes, here, and as you can see, in router 0, these routes are learned from EIGRP, and here also directly connected interfaces here, but these routes are also learned from EIGRP, and you can see the EIGRP administrative distance here and the metric value, and this is also in router 2. As you can see, router 2 also know all the neighbors. In the routing table, only the PC interface is not available, because it's also passive interface. And this is for router 1. And for router 3. Let's lastly verify the routing paths on router 0. Here, as you can see, router 0 has EIGRP routes for the last PC, and saying that via 10.0.0.2 this route is reaching to the last PC, and let's trace route for this. This is our routers interface, and as you can see, firstly our packets are going 10.0.0.2, and then they are coming 30.0.0.2, and our last point is here. On this basic EIGRP topology, we have talked about how to configure basically EIGRP. And we configure the passive interface, and on that interface the neighborship has not established, but that route has advertised to the other nodes, and all the routing tables has all the routes, EIGRP routes, and all the topology databases are identical.